Hi students, in this session I am going to take about the fluid kinematics and dynamics. So before getting into this, first you should understand that what are the classifications of fluid. So here now we will see about what is the fluid kinematics and what are the classifications and what are the applications of studying the classification of flow as a civil engineer. So now if I am taking that, where we are using this, so where this the flow problems will occur and where this kinematics and dynamics going to be used in civil engineering. So the first one, if you are taking the pipe flow and there may be the friction losses all will be there, and also there may be the sudden pressure drops, and also there may be the flow rate variations will be there. So there this fluid dynamics is very important. And if you are taking that channel flow issues, so whenever the fluid is flowing in open channel, there may be the sudden turbulence may occur, and there may be the sedimentations there you should understand the concept of dynamics. And also in aerodynamics dynamics also we are using. So where that the drag and lift forces are acting, and where the places where the boundary separation is acting, there in that places we are using this. And also in fluid machinery to find out the efficiency of the pump, and also the performance of the pump or turbine, and also where the places the cavitation problems are occur, there this fluid dynamics and the kinematics are very important. First we will see that what is the meaning of fluid kinematics. So here the fluid mechanics is nothing but studying the behavior of the fluid. Okay, so whenever if I am taking that, if I am finding the velocity, acceleration or flow pattern in some points, okay, and if I am not considering the forces which are causing the motion, means that is the fluid kinematics. So now we will see the classifications. So the classifications are steady, unsteady, uniform, non-uniform, laminar, turbulent, compressible, incompressible, rotational, irrotational, and 1D, 2D, 3D flows. So now we will see about first the steady flow. So you can see that how the flows are occur in steady flow and unsteady flow. So if I am finding the properties like velocity, the pressure, density, if I am taking at equal interval of time, if it is not changing with time, okay, which means we are calling that flow as a steady flow. If I am finding that the property in some other place, if it is changing with time to time this property is changing, means we are calling that as a unsteady flow. So therefore the steady flow is the no time dependence, but the unsteady flow is the time dependent. Okay, so if the time varies, there may be the chances of the variation of the pressure and velocity and density. So in most of the cases we can see that unsteady flow. And now we will see the uniform and non-uniform flow. So if I am taking that, the velocity, if I am taking that x direction, y direction, z direction, if the velocity is constant in all direction, means it is a uniform. If it is varying with the direction, means it is a non-uniform flow. So you can see this diagram. Uniform flow, the velocity is velocity, temperature, the pressure is not changing at any point, if different point if I am taking. So but in non-uniform flow, the temperature, the pressure and also the velocity which is changing. Okay, so therefore the at given instant of time these property get changed. So now we will see that laminar flow. So what is a laminar flow? So the laminar flow means the flow of particle will be in well defined path. Okay, and if it is in it is not well defined path, we are calling the turbulent flow. So to find out that, we are using the important number, Reynolds number. So if I am calculating the Reynolds number, if it is coming less than 2000, I am calling that as a laminar. If it is more than 4000, it is a turbulent. If it is in between, it is a unstable, that is a transitional flow. So here according to this number only, we are designing the given flow is a laminar or turbulent. So next the important the interesting phenomena is compressible and incompressible. So if I am taking the compressible flow, if I am finding the density, if I am finding the density at different points, it will change from point to point. So for an example, the best example is a gas. The LPG gas we are using in our for cooking. If I am finding that the density it is not constant, okay, it may be vary from point to point. So so therefore, whenever I am applying the pressure, the density will be increased. So, but if I am taking the incompressible fluid, so the best example is the water. So, if I am filling this jar with the water, is it possible to compress? No, you can't compress. Okay, and also if I am finding the density at different points, it will not change. Okay, it will be constant. So, that type of liquid we are calling that as a incompressible. And next one is a rotational irrotational. So if I am taking that the fluid particle which is along in moving along in the well streamline, and also if it is rotating about their own axis, so where we are calling that as the rotational flow. If it is not rotating about their own axis, means we are calling that as a irrotational flow. The next one is a 1D, 2D, 3D. So what is the thing? If I am finding the flow may be in different three directions only. Okay. So if the velocity is varying in only in x direction, it may be varying in y and z direction, but it is a negligible. Then we are calling it a 1D. If it is varying in 2 dimensions, the another third one is a negligible, means 2D. If it is the velocity is varying in all mutually perpendicular direction, means we are calling that as the 3 dimension. The example for 1D is flow in a long straight pipe. Okay, so that the flow will be in either x or y or z direction. And if I am taking the 2 dimension, so whenever the flow is some wide weir, so the and also spillway. So spillway where the place it is constructed in the dams. Okay, so the water will be moving and it will be in the variations of velocity will be in 2 direction. But if I am taking that the flow around the bridges or pier, so whenever constructing the pier in the some river, the flow will be moving here and there. Then the velocity will be varied in 3 different directions. So where we are using this phenomena, if I am taking that the open channel flow, where the dams, river channels, canal systems and the pipe systems, where the water distribution, sewer networks, industrial pipeline, and also whenever we are going for the hydraulic design structures, that is the dams and reservoirs, where it is very important. And also the important thing is the coastal engineering also, where we want to design the breakwater design and the harbor hydraulics and then the sediment transportation. The everywhere this this concept is very important. So I think from this lecture you have understand that what is the fluid kinematics and what are the classifications and where this used in the civil engineering. Thank you.